Welcome to my YouTube channel. I'm going to solve a question on static equilibrium. So as you can see, we have this question which says, in the figure below, a uniform horizontal beam of mass 20 kg, length 8 meters is attached to a wall by a hinge. Its far end is supported by a cable that makes an angle theta 30 degrees with the beam, and it provides tension. If a person of mass 60 kg stands 2 meters away from the wall, find the tension in the cable and the horizontal and vertical components of the force exerted by the hinge. Okay, so before starting to solve any question, you have to know the rules when starting to solve. So, what conditions must an object have to be in static equilibrium? So, things to know. So, for an object to be in equilibrium, the first condition which has to be met is the sum of the forces on the x-axis should be equal to 0. So the sum in the x may either be left, right, should be equal to be 0. They have to be balanced. Okay. So that's the first law. So the second, which says sum of the forces in the y direction, the y component should be equal to 0. Either be left, up, down. Forces should be equal to 0. And third is that the sum of all the torques acting on an object should be equal to 0. The torque is just moment. Torque is moment of a force. And moment is, the formula for moment is equals to force times distance, the perpendicular force. Okay, so we know this. Now we can dive into the question. Let me delete everything here, delete everything. Okay, so the first thing you should have to do these kinds of questions is to draw a free body diagram and show all the forces acting on the beam. Okay, so we have this wall and the cable running from this side to this side and attached to the wall or to the hinge. The hinge is this part. This is our beam. Okay, and this is our wall. This is the person. This is our angle theta. So now you have to find all the forces acting on the beam. So we have the tension. So to solve these questions, all the forces should be either in the x and y components, and all the forces which are not in the x and y components, we have to resolve them into their x and y component form. So let's start for the tension. As you can see, the tension is neither in the x or in the y direction, right? A component. So we have to resolve them. So to resolve them, you just draw one vertical line going on top and one horizontal line. Okay. So how do you know that this one is sin theta, this one is cos theta? So the one closest to the angle carries the cos theta. The one furthest away from the angle carries the t sine. Let me write it this t sine theta. Okay, so we have resolved the tension into its x and y component. We have been taught that the mass of the beam is 20 kg. So we have to find the weight which is acting on the beam produced by the beam itself. So to find the weight, we use the formula W is equals to M, weight is equals to mass times acceleration to gravity. So the mass is 20 divided by 9.8. So 20 divided by 9.8 is 196 newtons. So where is this weight of the beam acting? So the weight of any object acts at its center. So the center is where the force, the weight of the beam will act. Okay, so we have to show. So approximately it's this part here. So we have to show 196 newton. It's produced by the beam itself. Okay, and we have the forces produced by the hinge, which is Ny and Nx. Okay, and also the force produced by the person, which is we have to find, we have been given in the information. So let me lab this part, which is, so we keep the formula. So the weight, what was the mass given of the person? So the mass of the person was 60 kg. So to find the weight is simple, you have to use the formula. So weight is equals to 60 multiplied by 9.8. So 60 multiplied by 9.8, which is 588 newtons. 588 newtons is produced by the person. 588 newtons. So we have found all the forces acting on the beam. So the distances, the person is 2 meters away from the hinge, and the whole distance is 8 meters. Okay, so let me delete everything here. We have drawn a free body diagram. So now we are going to use those same laws to find the tension and the horizontal and vertical forces acting on the hinge. So our first law was that sum of the forces in the x-axis should be equal to 0. So which forces in our free body diagram are in the x direction? So we have our first force, which is nx. If you can see nx, it's right here. Okay, so nx, and our second force in the x-axis, it's t cos theta, and t cos theta is going to the west direction, so it has to be negative. So, and as t cos theta, we write it properly, should be equal to 0. Now we have to make equation. So nx should be equal to t cos theta. So this will be our equation 1. So you know our equation 1. Let me write it on top so that we can get more space. So let me delete this. I've accidentally deleted the line. Oh, let me put back like this. Okay, let me do it well. I've deleted the other important things. Okay, now let me write it on top. Our first equation was nx is equals to t cos theta. Okay, this is our first equation. We've created our first equation. Now we have to go to our second law, which was sum of the forces in the y direction should be equal to 0. So which forces are acting in the y direction? So our first equation, it is ny. Okay, first force, it is ny, like this. And any forces acting upwards produces a positive result, right? So any force acting downward should be negative, upwards positive. So the other force in the y direction, it is t sine theta. So that's it, t sine theta. Okay, so we all the forces going upwards we have looked at them. So now the other forces are acting downward, so we have to subtract them. So the first force in the downward direction, it is 588. So minus 588. And the other force, it is also downward, it's 196 minus 196 and equals 0. So let us simplify the numbers. So 588, negative 588 minus 196, I get negative 784. Negative 784. So ny plus t sine theta is minus 784 is equals to 0. Take the negative part to the other side. So ny plus t sine theta is equals to 784. Okay, so this is our second equation. Okay, so let me create more space so that we can solve cleanly, can see cleanly. So delete everything here to get more space. So let me write it on top. And y plus t sine theta is equals to 784. This is our second equation, so I'm writing them on top there. And delete everything which is remaining. Everything are deleted. So we have only managed to get this, but this is not enough to get what we want. Okay, so we have to use our third law, which was the sum of all the torques should be equal to 0. Okay, so to find the torque, it's just moment. So torque of the first part, it's so we have to find the torques which are going downwards, which are producing an anti-clockwise and clockwise moment. Okay, so which ones are producing an anti-clockwise? It's the t sine theta. So it's t sine theta times the distance. The distance, it's 8 meters, because the sine theta, it has a distance of 8. The formula for moment is force times distance, right? Yes, force times distance. Times distance, this is for the anti-clockwise part. So the clockwise is always negative, so minus the downward forces, which are 588. The force of the person, which is 588, the distance of 2 meters. Okay, so 5 times 2. Okay, the other part is 196, but the distance we don't know. We only know that it's acting at its center. So at its center, it means it's half of 8. So the distance here, it is 4 because it is acting at the center. The center means half, so half of 8, it's 4. Okay, so we have 190, 196. So minus, it's acting downward. 196 times multiplied by 4 is equals to 0. Okay, so we have to simplify. T, the angle which we are given in the question was 30 degrees. Okay, 30 degrees time multiplied by 8. So negative 588 multiplied by 2, which is 1176. So negative 1176. The part here, negative 196 multiplied by 4, which is 784, minus 784, which is equals to 0. Okay, we have our set of equations here. So we can simplify further. So sine 30 multiplied by 8. So sine 30 multiplied by sine 30 multiplied by 8, which is 4. So here we have 4t simplified. Okay, and we can simplify there. 1176 plus or minus 784. We have 1 negative 1960 equals to 0. So we can take the number that side and remain with 40 here. 960, and to remain with t, we multiply by 4 both sides. So 1960 divided by 4, which is t, gives us 490. 490 newtons. It's the tension. So we have found the tension. Okay, so the tension is 490, so we can write it on top there. We can write it on top, 490. Tension is 490. Tension is 490, so keep it in your head as I'm deleting. Tension is 490. Tension is 490. We put it tension. So therefore the tension, it is 490. So we have found the tension. The tension, it's this. And now we are told to find nx and ny. So can plug the tension in the formula, the equations which it derives. So we can write for nx, we add nx is equals to t cos theta. So our first equation was nx is equals to t cos theta, and we can just plug in the values which we have. Nx is equals to our tension was 490, 490 multiplied by cos, our angle which we have been given is 30 degrees. Okay, so you punch it, 490 divided by cos 30, which is going to give us nx, the value approximately of 424.35 newtons. So we have found our next nx. So therefore nx is 4 to 4.35 newtons. Okay. We have, so let me delete it. There are other things here. Let me delete the other things here. Okay, I've deleted, it was taking a lot of time, so we have to find for ny. Okay, so for ny we have ny plus t sine theta is equals to 784. So we just have to plug in the values. Okay, so ny plus our tension was 490 multiplied by sine 30 is equals to 784. Okay, so 490 multiplied by sine 30, which is giving us 245. So ny plus 245 is equals to 784. Okay, so now we take the like terms, we group the like terms together. 784 minus 245, so 784 minus 245 is giving us 589. So ny is equals to 539 newtons. Okay, so let me put it there, the other values. So ny is equals to 539. Okay, so let me delete this so we can write the numbers properly. So these things, I have to delete them. Okay, let me delete them. Let me pause the